Okay, we can go ahead and get started. So this is a one-off meeting of the CSI Community Group. Today is February 11. And so the primary reason for this meeting was to continue the discussion around CSI changes for volume health. And before we get to that, looks like someone also put another item on the agenda. What is the behavior of the create volume request with empty capacity range? Is this person on the call?
Dimitri's not on the call, but I can represent him.
Okay.
Yeah, basically he's asking for clarification on the spec. Right now, the spec says the plugin may choose, or if it's empty, the plugin may choose a default, but it's unclear if the plugin can also return an error or it must return a default. Or I guess here it says it may return a default. So I guess what that implies is it could also choose not to return a default and error.
Yeah, I guess his question is like, if it's an error, what the error code will be. That's my understanding.
In this case, does he want to return an error? Is that what he wants to do?
He wants to clarify what is allowed. Like, is the plugin allowed to return an error if it doesn't want a default?
That would matter if you were doing like a conformance test or something.
Yes, he's writing a conformance test.
I mean, just by reading the wording of that one line, it seems to allow for the case, because may means it's up to the CO to choose, or the storage provider to choose. I have no objections if somebody were to return an error here based on that line, and thinking through the logic of what would happen. I think it seems perfectly reasonable to be able to return an error on that call. Anyone else have thoughts on it?
Yeah, what error code will be? That's the question. Like invalid argument?
Invalid argument seems reasonable.
Okay,
basically, the SP expects something and you know, it's not there, so.
Okay, that's fine. I think what that means in terms of writing a conformance test is that the conformance test always has to pass in some value.
Well, no, it means that if you pass, you should have a test that passes in nothing, and.
But you can't, like, if you pass in nothing, it either succeeds or fails.
You could validate that it didn't crash. That would be a good thing.
Yeah, I guess.
I mean, something could crash in response to getting nothing, and that would be bad. Or you could validate that if there is an error, that it is at least the invalid argument error. Yeah, it seems like a not particularly valuable test, but.
Yeah, I think the more useful test is actually passing in something and making sure it works.
Yeah, I don't know if we need to really be more prescriptive here. I think, like Ben said, just make sure it doesn't crash. Okay, any more discussion here? Okay, cool. Let me just put a comment here. All right, so moving on to the main item, CSI changes for volume health. I will stop sharing and hand it over to Xing.
Sure. Let me share my screen. So I just want to continue with where we left last time. I submitted a PR with the some of the changes. So I get rid of those common error code that we were suggesting. So now we have this severity level. Let me go to this. Okay, so basically for we'll introduce a new message for the volume house, and here we have a severity. So Jeff added some comments here. He said it should be code condition, not severity. And then so there are 5 levels: unknown, healthy, temporarily unhealthy, and fatal, imminent. I think there's a typo here. It's imminent and fatal. So this was what we discussed last time. And last time, I think we had some question on how to differentiate between the error codes, between the errors reported from the controller side and from the node side. So I think that if a CSI driver has both controller and node plugins, it of course should try to report different type of errors. So I'm just thinking about from our driver point of view. We have both controller and node plugins. So the controller side will be communicating with the storage system to get all the health information from the storage system itself. But from the node plugin, we will just be, we will not be communicating with the storage system directly. It will just be getting information from that node specifically. So whether the volume is still mounted, whether there are some rewrite IO errors, those type of things. So it should be different. So if a driver implement both, then those should be different type of errors. So for a node side, it should be specific for that node. Even for a driver that only has a node plugin, then that error from that particular node will still be specific for that node. So I think this should be okay. Anyone has any other?
So I want to make sure I
comments?
understand that correctly. I think,
Mm-hmm.
are you saying that if a controller and node are both implemented for health checks, the things that they're going to be checking are very different?
Yeah.
And so as a consumer, you don't have to worry about a different signal from the two, because ultimately they're checking for different things, and a unhealthy on either one means that something bad has happened.
Right. Right. So specifically if it's something from the node side, then that is specific for that node. So if it's a controller side, then it's basically going to.
And so I guess the weird thing for me now is like on the Kubernetes side, we're only going to be able to get a node signal while the volume is mounted. And so let's say it's healthy, and then it goes unhealthy while mounted, and then it gets unmounted. How long do we assume that it is unhealthy if it's not mounted, or do we do anything with that signal while it's unmounted?
So basically so that is specific for that node, right? So if it is not healthy, then we could try to do remount, right? So for that particular node, if the node really goes down, then that's a different story. Then you need to try to move that volume to a different node.
So I'm going to push on this a little bit because it sounds a bit strange to me.
Okay.
Like, so you're saying that if we call node health on a particular node, and there's some systemic problem on the volume itself, that should also be reported by the controller?
No.
So well, let me finish the question.
Okay.
Maybe I'm afraid I'm not being clear. So just a minute ago, you said like the node is only going to report problems that are node specific, and to me that seems that's where I'm getting a little stuck, because
okay.
uh, if the volume is unhealthy, then I would kind of expect all of these checks to report it back unhealthy, even if it's just like, you know, like the 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 storage itself has failed.
Okay, so I think depending on what type of storage, right, you're talking about. If it's like local storage, then of course your node is your storage. Then in that case, of course, it's different, right? So you are talking about a storage and node kind of together. So in that case, normally those type of drivers only implement the node plugin.
Mm-hmm.
So I think there should no, in that case, there won't be confusion. It's just node plugin will be reporting this type of information, right?
Right.
So it's only if a driver implemented both controller and node plugins, I think we're talking about there could be some confusion coming from if you have information coming from both, and then they are kind of opposite. What do you do? So I'm talking about in that case. So I use our driver as an example. Then in that case, our controller side plugin will be checking the backend storage system. Our node plugin does not communicate with the backend storage system. It's only looking at the mount information. So
I see.
yeah, so
That I think that makes sense. Thanks.
okay.
And so I think what you're saying is the signal from the controller is kind of, it should be, you should be able to use it at any point. Whatever the signal is basically indicates the underlying storage is healthy or not healthy. And then the node level only gives you information about the mount and is only relevant while the volume is mounted and should only be used to, operate on the mount, and that's it.
Right, yeah.
So sorry, my audio dropped out for like 30 seconds there. I think we can agree that in the situation when you have an SP with both a node plugin and a controller plugin, the controller will know some things the node doesn't know, and the node will know some things the controller doesn't know. And so both pieces of information are interesting, right?
Mm-hmm. Yeah.
The one that confuses me more is the one where you don't have a controller plugin. Is it realistic for the node plugin to be able to give you the kind of information that a controller plugin would have given you in a deployment where there was a controller plugin? Like
but then it kind of add this burden for all of, because there are I don't know how many, but there are quite a few drivers that only supports node plugin, because only node plugin is required, right? So now you're requiring them to implement an additional controller that gather all the information, kind of aggregate all the information from all the nodes. It's just an extra requirement. I just don't think we should go that way.
I guess the thing that's making me uncomfortable is it feels like something's missing in that case. Like we have this notion that the controller plugin is optional, but it's like that there's this job that needs to be done, which is like, give me the health information. And we're saying, well, sometimes you just don't have a controller, so the job will fall on someone else. And it's like, well, maybe there should be something whose job it is to address these kinds of questions in a deployment where you don't need a traditional controller plugin. And I don't know what the answer is, because I'm not too familiar with these kinds of storage systems, but it doesn't seem, I mean, the node plugin's job is so limited to just, attaching volumes and detaching volumes. It doesn't know anything about taking snapshots or provisioning or, all the other things that a controller plugin does. But health seems like the kind of thing where it really should be able to give you the answer. And just saying, well, sometimes the node plugin is all you have, and sometimes you have the node plugin and the controller plugin, feels like it's dancing around a deeper problem that you need.
Yeah, I think what you're saying, if I can rephrase it, is the controller health check can be called at any point, regardless of whether the volume is attached or mounted or not. And so the CO can depend on that at any point to understand what the health of the volume is. On the node side, the only time the CO can depend on a signal from the node volume health check is when that volume is mounted. In the normal case where you have a plugin that implements both, this should not be too problematic other than the two signals thing. But if you have a plugin that doesn't implement controller is optional, then you only have the node signal, which means you only have information while the volume is mounted. So something is missing, and you're hoping for something more robust in that case.
So something that's kind of, yeah, that has the aspects of a controller plugin with maybe not all the requirements that come along with that, so that, yeah, a CO could ask what's going on with these volumes even when they're not mounted. Yes, that's what I think is needed.
Do we have a concrete example of that CSI driver that has only no plugin but no controller plugin and having this issue?
It would be like a local volume plugin.
Right, and a local volume plugin could absolutely have code to do like smart monitoring on the disks and stuff to tell you what, whether they're in good shape or not.
Oh, I see. So the no plugin in Kubernetes, oh, sorry, the local volume support in Kubernetes, like only have no plugin. There's no controller plugin.
I don't think there is a CSI driver for a local volume, but hypothetically, if one was written, it could be written without controller.
And if someone wrote one for LVM,
but how do you do dynamic provisioning if you don't have a controller plugin?
It doesn't.
Okay, so there's no dynamic provisioning.
Correct. And you can even have things like NFS plugins that don't do dynamic provisioning, and they would only have a node plugin.
Yeah, the existing NFS6 driver does not have a controller plugin. Yeah, it's on a node.
But like a driver like that can't get health information because NFS doesn't provide health information.
So maybe that's okay, right? Like we can decide that if you are writing a simple driver and you do not implement controller, today you don't get volume provisioning, and in the future you do not get this, permanent, robust volume health monitoring. And if you are a driver that really wants that, you have to implement a controller. Is that too high a burden?
I don't think so. I think actually if you look, you'll see that the NFS plugin, even though it doesn't need it, implements a controller plugin. It's like a little no-op, one file. So this isn't really a burden. It's pretty easy to make a controller plugin.
But I guess it's slightly different than the local one. If you want to support local volume using CSI and you want to run controller plugin to do dynamic provision, you have to run the controller on every single node.
Or you would need a way for the controller to reach the nodes and get the information you need.
Or you have some back channel to reach the
nodes. Which would be more burden than, I mean, that would be a pain, right? Making that back channel to every node. It's a whole bunch of management for nothing. No.
Interesting. Actually, in our system, we actually have, like, to support local volumes through CSI, we run controller plugin on every single node to do dynamic provisioning, things like that.
Is that LVM based?
Yeah.
I think let's.
Well, I guess my point, if the problem is only limited to like local volume support, I think maybe we should ignore that for now, because I think the implementation between COs are slightly different, I think. But if there's other plugin like NFS that you want to get the volume health, I think NFS, I don't know if NFS makes sense, because I think, can you get the volume stats without mounting the volume?
I could imagine that if you had a specific NFS plugin that also did provisioning on the NAS, then you'd have some back channel to the NAS where you could do that kind of monitoring. But just a normal NFS plugin where you're mounting some random NAS, then no, you're going to know, like, you're going to know the health of your mount point, right?
I see. So, okay, got it.
So if there's I/O errors from the node side, does the controller report? Do all controllers know how to report that?
That's from node plugin.
Because from the
The
controller,
IO errors should be from the node plugin.
yeah. So don't we want to expose that, or is that different?
So we
or-
still need we still need okay. I think we still need both. So those are different type of errors. I think right now we're talking about if a driver only has node plugin, what do we do? I guess that's we are trying to decide.
I mean, I would be fine to say if a driver only supports the node plugin, then the amount of health information that you can get from it is going to be limited. I think that's fine. But I don't think we should just not support them at all.
Yeah, I think that we should support that, because I think that's actually initially that was actually the initial use case for this feature was how to get those information for local volumes. That's how this how things get started.
I think the part that's missing from the design is like, what exactly should the CO do with all this information? So the CO is going to have two different ways of getting it, but like, we need a prototype or a example of like how you collate and do something useful with the data you get.
I think we have already said that right now this is only reporting the events, right? So we are not going to, the CO is not going for this phase, it's not going to do any correction.
Right, but I mean, in particular, an example of how the CO will handle the two signals, the controller information and the node information. And as Saad mentioned, like if you get a bad signal from volume and then you unmount it, should you remember that it was bad or should you forget it? I mean, there's little subtleties like that.
You know, that for that particular one, then that we should do a remount, and then that's the node side, right? That one I think is. So I think there are some specific error code that we talked about earlier that maybe we could do some reaction. Not all of them we can do, but like if it's not mounted, we could try to do a remount. That would be from node side. That's not the controller side, definitely.
It just seems like there's a high probability of getting what do you call it? Unstable signals, where the signal is changing and you're getting a not consistent view of what's going on from the CO's perspective. And that's not helpful to a system that's trying to react to these things. And we're not designing that yet, but ideally that would be step 2, is once you have the signal to do something with it. And if the signal itself is unreliable, that makes it much harder.
No, when you get an error, you will depend on what kind of error. If it's like the temporary thing, then you're supposed to wait for a while and then you go try again and see if it still stays in that error, right? Hopefully they will come back. If it doesn't come back in a certain amount of time, then maybe you want to do some reaction. So I don't see why they are unreliable. You're talking about it coming from both control side and the node side. So from node side, well, if it's coming from, I think we already talked about that earlier. If like our driver has both controller and the node plugins, they give you different type of errors. So you're not going to get from controller side. So it's not mounted, and node side tell you it is mounted, because that information is only coming from node side.
I guess what I'm thinking about
based on that, it should be doing something.
Is you're going to be receiving multiple. Presumably you're polling, right? Like on some interval every minute, every 5 minutes, whatever. And like you'll get some information, then you'll get some more information, and you're going to have some notion of what the world looks like. And newer information should replace older information, but only to a certain extent. Like
there will be so when we finally bubble those up, let's say if we have a PVC that has this information in the status or somewhere, then there should be like when was the first time this error happened, how long it has lasted. Based on that, you can do some type of reaction, right? So how long this problem, you don't want to react immediately, maybe if it's temporary, but if it lasts for like a day, then you probably should do something.
Yeah, I'm thinking about like errors that might appear and then disappear, and the fact that they happen.
If it disappears, then that's if it disappears, then that's the temporary error. Then it's
Can we just forget about it and say, oh,
yeah,
never worry about that again. Forget it ever happened.
Well, if your error, if it's, so depending on the error, right? So look at the severity that we were talking about earlier. If it's the temporary thing, then of course, if it's not, if it says healthy now, then of course, then we should just ignore that, because then that's a temporary. Supposedly, that's what should happen. But if it says fatal imminent, then you should react immediately.
So I guess the main thing then is just to point out that, you know, a new controller signal should replace an old controller signal, and a new node signal should replace an old node signal, but they shouldn't replace each other. So
right.
like,
So right now we don't. So right now since we are only doing the events, right? So event will come and go. It's not going to be, So when we come to the API design, then we need to look at that. Basically, this will be in the let's say PVC status, have that information, right? So how are we going to do that? So I think at that time, if you get some error status as temporarily unhealthy, then when was the first time you get that, and then what is the last probe time? So we need to have all of those information.
Yeah, I think Shing, what I was imagining, if you want to implement a local volume plugin, most likely I will implement, if I was the one that implement this, I will implement a controller get health. And then once the CO calls that, it launches a pod on the relevant node, get the volume status irresponsive. I mean, regardless of like whether the volume is mounted or not, get the reliable information from that node, and then surface that back to the controller plugin, and then controller plugin tell the CO about that volume health information, so that you don't rely on the fact that the volume has been mounted to get the stats. You rely on controller service to do this. If I were the one that implement this, I would probably do this. Versus doing that in the node plugin.
Okay, so we should make this like a recommendation, saying that you should be
right. I mean, if you want to get reliable signal, I think sounds like the controller service is the right way to go. Versus you implement that just for the simplicity, implement that in the node plugin, having all these caveats.
But we do consider things like a corrupted file system to be a health signal, right? And that's the kind of thing that under normal circumstances a controller is not going to know about.
Right.
Only the node's going to know it, and we don't want to force people to create these back channels either. So in the situation where the only thing that's wrong with the volume is the file system got corrupted, that would be the kind of information you want to get from the node directly, and not force the node to tell.
Your point is like we need both. I guess.
Yeah.
I think we're stuck there. Yeah.
No, I don't think we're stuck. I think we do need both. Makes sense, right? Why we need a plugin and controller plugin anyway? Why we need two plugins?
Well, I think there's a sense that it would be simpler if we didn't need both, but we seem to be unable to find a way to do it with just one. So that's why I say we're stuck.
So this is the same, right? So when we implement plugins, we have both controller plugin and node plugin. So now when we get health information, you need both as well. For specific reasons, the different needs for both.
I can tell you right now that if we make this change to the spec, there's going to be vendors in the channel asking, what does this mean? How do I implement this? There's going to be lots of questions. We need to make it clear why there's both and what purposes they serve.
Well, I can think that from our job point of view, I think since we support both, it seems pretty clear to me that controller side and node side.
I think as long as we in the spec we make it clear, like, or maybe give examples of what you would put in a controller report in the controller side versus a node side.
Yeah, a few examples would go a long way.
Yeah, we should like different type of plugins. What are the suggested way to do this?
I want to go back to what Ben was saying about thinking through how we expect the CO to collate the two signals from controller and node. And I think what you're saying, Xing, is that that is not a goal for this initial iteration. For the initial iteration, the signals are just going to be surfaced up to the user. There's no programmatic response to it. In the future, as a follow-up, there will be programmatic response, and we can think through the implications of that then. I think it might be worth at least talking through it now to make sure we're not painting ourselves into a corner, to make sure that this is going to be useful. So it sounds like what we're saying is there are two sets of signals, controller and node. Both are going to be periodically polled. Controller can happen anytime after a volume is provisioned before it is deleted. Node can only happen while it is mounted. And as you get signals from both, you need to understand that they may give different information, but whichever one it reports unhealthy or anything other than healthy should be taken, should override the other signal. So if you have mount reporting healthy but controller reporting unhealthy, then you assume that the storage is unhealthy and operate as such.
Well, wait a second. I don't think that so. Those are two different types of information. We actually need both. So if the controllers, so because
I think that's what Saad was saying is you have to look at both signals and pay attention to the worst news that you're seeing.
Yes, agree. Yeah.
Okay, so then as a something that'll be operating on it programmatically, I need to look at both streams of information, figure out when is the last time I got a signal from each one. And so if I have a signal from node that's saying unhealthy, but controller says healthy, but the node is now unmounted, what do I do in that case? Do I ignore that signal while it's unmounted?
Node says it's unhealthy because it thought it was mounted, but in reality it's not mounted anymore.
It was the last seen state. So it was, the last state that I saw while it was mounted was unhealthy, and then the user deleted the pod, and so it got unmounted. And now it is unmounted. Do I assume healthy or unhealthy for that?
So you said user deleted that, then it's not in use anymore. Do we still need to worry about that for this particular volume? If we are,
I think you would keep the last sample you got from that signal, and until you mount it again and get it's all good from the new mount. Remember what you saw.
But do you operate on that last state? Do you do anything with it?
Well, I think we were intentionally punting on that question because we don't know what we're going to do in any case.
Yeah.
So,
but you certainly store it and report it in the sense that as far as you know, like the file system is still corrupted if that's what the signal was before you unmounted it. So, well, last time I checked, it was corrupted, so there's no reason to believe it got fixed. And if you want to clear the bad signal, you go mount it somewhere and see, and then get the status again.
I think before we react, we need to check the health status again before we do reaction, so that we're not reacting only based on stale information.
So that, I like that, but then what I'm worried about is that there's no way for this system as it's designed to guarantee that the signal is not stale.
But if you have a way to make a call to your storage system again, then
right. But
that
as
way,
you make the call, it could be out of date, right?
but that should, well, that's supposedly your storage system can provide those type of APIs for you to
kind of
query, right?
Any kind of polling is always going to be a little bit out of date.
Yeah.
You have to decide what you're willing to tolerate as far as staleness. few seconds, a few minutes seems like it's okay. I mean, I think the problem with any kind of a health monitoring is you have to do like a heuristic response. You can never have this is definitely the right response. And so you're always kind of guessing about, should I abandon the storage and go get some new storage because of some probability that something bad will happen?
Yeah,
You're
I
always
think
guessing.
that's probably what it boils down to, is we're never going to have 100% confidence signal. So instead of the consumer, like, I think the worst thing that we could have is something that like responds immediately to one of these signals. So it sees, oh, this thing is unhealthy, let me go and respond to it, because that could result in some sort of ping-ponging, or like, oh, let me just delete this volume and create a new one, and oh, it's unhealthy, let me delete and create. That would be a really bad thing to do. So maybe as part of the recommendation, when we say, if you're going to use this for programmatic response, you have to, monitor for some period of time or something, and build
I
up.
mean, at least in its current state, you can't really programmatically respond to it, right? Because it's just a string. So every single driver is going to return their own random strings.
We do have severity in there, right?
Yeah, the
Yeah,
severity is
severity
meant
is
to be
common. Yeah.
the thing that is agreed upon.
Yeah, but you can't really like react to a severity automatically without really knowing what kind of error it is.
I mean, someone can say a failure imminent. If I see a failure imminent, I don't care what it is, I am going to do something programmatically. That would not be unreasonable, I think.
Yeah, and you would just need to make sure that whatever implementation of a CSI plugin you had didn't lie to you about that
Right.
kind of thing. So that would be a deployment issue. If you had a really buggy CSI driver that was always throwing off weird errors, that's a different problem. But assuming that the signal is worth something, yeah, I would react to that and say, oh, if someone thinks the storage is bad, I'm getting off of it. I want to stick to the healthy stuff.
So I don't want to derail this by saying let's focus on phase 2. Phase 1 is we're just trying to be informative to the end user, and that's fine. But I just want to make sure that we don't paint ourselves into a corner where we do phase 1 and then we don't have a viable path to phase 2 where we have programmatic response.
I'm thinking that the phase 2 thing will need to be tunable based on how, with some knowledge of exactly how noisy the underlying CSI plugin is. Because some CSI plugins might always return healthy always and never return an error, while others might warn you of the slightest possible thing that went wrong.
So we have severity levels, right? So.
Well, but we don't. I mean, like failure imminent just means I think something might go wrong in the future, but that could be as simple as, I detected that a fan in the enclosure stopped spinning, and so, that the failure could be happening soon, but that could just be that the bearing went out, right? It could be a really minor thing that the system detected and says, oh, I want you to know about this. And you don't want to immediately migrate terabytes of data because a fan stopped spinning. But but that requires knowledge of exactly how noisy the underlying health monitoring is. And so I guess what I'm saying is that the reactive system has to be tunable based on knowledge of how often errors come in, and that's going to vary from implementation to implementation.
Yeah, if we end up doing that, that's going to be a lot harder. Ideally, we don't have to do that. is there a way to get drivers to agree on kind of sensitivity and, hey,
Like, can we, when we describe the severities, can we be very specific about what, like, thresholds of severity?
I don't think you can, other than to get out like literally returning a number, which is like a probability estimate of failure. And that's a black art.
Yeah, this doesn't feel to me like something that makes sense to put in the CSI spec in this moment. I think like this seems like something that needs to be experimented with. Like, so if those recovery mechanisms don't exist yet in any CO, and this is something that we're introducing into CSI to create this data channel so that we can maybe start to build those recovery mechanisms. It feels too early to me to make any statements about how the CO, what the CO is going to do with this, because probably in the initial go round, right, the CO is just going to report it, and that's it.
So I agree. I also think that it's a little bit of a chicken and egg problem. We need something in CSI to be able to start building something on the CO side. So I think the proposal here now, in the past, what we've done is whenever we stuck something in CSI, we've called it GA effectively.
Uh-huh.
That has been, at least with resizing, it was not a great idea. And so now what we're proposing for any new functionality that's going to go into CSI is to go through an alpha, beta, GA. And so the proposal here would be alpha in CSI, and then like go back, try and implement it in the CO, see if it works, and iterate on it. So it wouldn't.
Yeah,
Final
yeah.
edition.
Just to clarify, I wasn't saying the proposal, I wasn't criticizing the proposal in any way. I was just saying that I think trying to make statements about how the CO will recover when a volume is unhealthy is
Gotcha.
premature.
I think yeah. Okay, that makes sense. So maybe we punt that for our future selves to figure out and say that is a known issue. We haven't really thought through how the programmatic response is going to work. In the alpha implementation, we write stuff that says CO should not use this for programmatic response, or no one should use this for programmatic response. This is only for informing the end user. And then we start prototyping and playing around and seeing what makes sense, and then go from there.
Or you could make it even more squishy and say the CO may attempt to recover, right? I mean, I don't know what you know, we're just not going to make any guarantees or stipulations or anything because nobody knows yet whether it makes, under what circumstances it makes sense.
Can we say that the intended consumer of the information is a human and not a machine? Would that help? Like this information is intended for humans to read and understand, not for machines to process and respond to.
I guess that was to me that just
that doesn't say that you can't have a machine respond to it, but it better be a really smart machine.
Right. Well, or you know, caveat emptor, right? If you turn on volume recovery, you're getting an alpha feature, and it might totally burn you, right? I don't know. I guess I would lean toward leaving speculation about implementations out of this spec and just leave it as it stands until we have more concrete feedback of like, well, here's some things that we know we can do, and we've tried it and we've found it to be safe, you know.
Yeah.
I do think you could put verbiage around, you know, the error, the strings, and say, look, these strings are opaque, and I guess if you call the strings opaque, it's clear what that means, right? It means that you can't interpret them
The
reliably.
strings, I think I'm less concerned about the.
But the severity levels, I think we could specify that they cover a range of possibilities. You know, failure imminent could mean maybe failure versus highly likely failure, and we're not being. You can just say it covers that range. Failure hasn't happened yet, but there's reason to believe it will.
Yeah, that's hard to define in a way that is that can go into a spec. Like even something like highly likely is not.
Well, no, I think you'd want to emphasize the non-specificness of it, that it's
Okay.
elevated above normal, but we're not telling you how much.
Which kind of defeats the whole purpose of having an enumerated.
Well, some information is better than no information.
Yeah.
In a situation like this.
Government terrorist threat level. That's all.
I think
we should do color codes, right? Green, orange, yellow.
Yeah, I think that's simpler. I think the two middle levels that I think there will be a lot of people coming and ask, okay, can you tell me this situation, should this be temporary or should this be imminent? Probably will get lots of questions like that. So there's a two middle, there's two levels in the middle. People probably
should we for phase one not have severity at all and just have opaque strings that get surfaced up? Or would that make prototyping difficult?
I think the severity is important, but I was wondering if we should combine this temporary, unhealthy, and imminent. I don't know if people know
I
how
actually
to
feel strongly.
I
feel strongly that those are very different situations.
Because I suspect we'll get questions on Slack all the time. Okay, can you tell me this one should belong to this one?
The essential difference is, like, has it already failed or not? You know, if it's already failed, like,
so it's not right. So fatal, healthy, unknown, those are fine, right? So this middle one.
So a temporary failure means that, like, right now, it's failed.
So temporary, does that mean? So can you still write? Can you still have access to your volume? Do you lose access to your volume?
Yeah. That's what it means. Is you've lost access for now, but
how long, right? So let's say
that's what you don't know. That's what you don't know.
So
but
there's a big difference between.
There's a big difference between I've lost access now versus, like, I still have access, but I detect something weird is going on.
I mean, so then you come back like one day and okay, if it stay in this state forever, then you can't tolerate that. Your application probably cannot tolerate that for a certain period of time, right? Then you need to react.
Well,
so even though
some
it's
human
just
some human has to do a cost-benefit analysis of how long it's going to take to fix the problem versus, should I just give up and start a new replica? And that's going to depend on the size of the volume, the amount of time required to replicate, for the difficulty in solving the underlying problem. I mean, it's that stuff requires a human to make that decision. But there's a big difference between, I've lost access to my data and it's gone forever, or versus I think it could come back.
But that's the fatal, right? I mean, I think
yeah.
If it's gone forever, then that's fatal. But this is
sorry. I want to make sure I understand what both of you are arguing. You're saying that you do believe severity is important as well as an opaque string?
I think there's value in severity, and I especially think that you have to distinguish between the current state versus the future state, which we've done with the four severity levels.
Okay, and Xing, what are you arguing?
Oh, so I also think we should have severity levels and also the opaque strings for our code. I think my question is this: you see this temporary, unhealthy, and fatal imminent. I'm just saying that we probably will get a lot of questions on, the driver maintenance I'll be asking, okay, I get this error. Should this be a temporary unhealthy, and should this be fatal imminent? So I think those two probably we need to clarify. Imagine we'll get a lot of questions on that. I was wondering if we can combine the two, but Ben was saying that he doesn't think they should be combined. They should be two separate.
Yeah, and I can help you add some words to that to try to make it clear, because I think there's a big difference between, like, a volume that is already offline and there's hope of bringing it back versus a volume that's currently online and it might go bad soon.
Yeah, it's just I just don't know if it's through system. I mean, some knows, but I don't, probably not everyone knows how to differentiate those two. And if they are in question, then which one do we probably should have some suggestion. Which way do they go if they don't have that much information in their storage system to know to differentiate those two? So I think it's just some clarification needed.
Yeah, and it could be that some implementations
Yeah.
will never return one of those states because they don't know how to detect it.
Yeah. So
But,
in that case, I mean, do we just suggest them to go with fatal, or I mean, one of the? I think that's something that we need to clarify in the spec, probably. How which one, which severity should they go with?
Okay.
I think I agree. There is a middle. Definitely, there is something in the middle, right? Between healthy and fatal, and there is something in the middle. I think need some more clarification on how to differentiate this number 2 and number 3.
Mm-hmm.
Yeah. Yeah, I'm fine to have those.
Like in general, there's consensus that we do want to move forward with this, with the acknowledgement that there are unresolved issues, especially around programmatic response. And we're saying that for now, we're going to punt that issue to future selves to figure out. And for this iteration, we're just going to add verbiage to say, don't use this for programmatic response or something to that effect. You're going to think through these different levels that you have here, especially number 2, and see how it makes sense with Ben. And then you're going to add examples to make it clear how you should use node versus controller, what kind of signals they should be returning. And we are okay with having both. If someone only implements node, they're going to get a reduced set of signals basically for their plugin. Any other concerns, comments, issues? Okay, so then let's take it to the PR to finish it off, or do we need another meeting to discuss?
I think it seems like we can just move on just to do PR reviews.
Okay.
I will update the PR with all the comments we got today.
And so if all the folks that were active in this discussion, please help review the PR, that would be great. Julian, James, everyone.
Yeah.
I think your feedback would be very valuable. It looks like a lot of you already are. James, I see, already has comments there. Ben too.
Oh,
Yeah.
Sad. Go ahead. I think Jeff has a comment on why shouldn't we use list volumes? We added the get volume. I think, Sad, you also prefer to have get volume, right? It's more clear that we are just getting information from that one.
Yeah, I keep going back and forth on that. Yeah. I do think that we were a little bit too strict on not introducing a get volume call or a get snapshot call.
Yeah.
We basically hacked around that by having filters on the list call.
Right.
We can continue to follow the same pattern or introduce a new one. I'm on the fence. I can be convinced either way. I don't see a strong objection to introducing get volume. I think the only objection I would have is consistency with the snapshot side. And then also the fact that we already have a bunch of volume plugins out there that don't implement it. So how much can we depend on it? But since we're introducing this as a new feature, any new volume plugin that wants to implement this feature is going to say, oh, well, I guess I also need to implement get volume to get this functionality. So we might be able to introduce it in this way.
Yeah, I think a lot of drivers don't implement list volumes because it's very expensive,
right,
to make that call. So, okay. And then Jeff also has the comment, rename severity to condition. I'm fine either way. So anyone has strong opinions on this name?
Strong preference.
Yeah. Makes sense to me. Severity healthy does just
a little weird.
Seem like strange English. Yeah.
Yeah. Okay. All right.
wanted to plus one what Saad said about get snapshot. That would have been really
Oh,
helpful.
that one we already passed. I think we already added a filter in there.
It's not too late to go back and fix that.
Yeah, I think as we think through this, let's figure out consistency as well.
Yeah, we could if it's actually good because because we didn't implement list snapshots because it's so expensive, and then if it's a get, then we will implement it. Yeah, so.
Okay, so then the next meeting is going to be in 3 weeks, which is going to be after Kubernetes code freeze at least. If there are any concerns, let's follow up on the PRs, and if PR starts spiraling out of control, we can schedule another one-off meeting to discuss.
Okay, sounds good.
All right, thank you all for your time.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.